My name is Tim Sheets, and I'm with HP. I am the Portfolio Strategy and Technology Manager for StorageWorks Division. And pretty excited to be able to come up here and talk to you about scale-out storage for the private cloud. So kind of set up a little bit of a premise here for you guys, and really what's driving people to the cloud. And before I do that, actually, let me ask a question. How many are service providers or partners providing solutions? Raise your hand. Okay. How many are actually end customers, IT guys looking to figure out how to go put the cloud in place? All right, a nice mix here. That helps me understand. So, as we go through and look at what's going on in the industry, we find some pretty interesting dynamics that are beginning to really affect customers and how they put the private cloud in place. And, IDC recently did a study that over 70% of businesses are now starting to consider using a private cloud. And there's a lot of reasons why, right? To get those efficiencies, to be able to drive that flexibility, that ability to dynamically change on the fly. And really the economics of, being able to save some of the cost of that IT infrastructure and leverage that better. But the dynamic that I think is the most interesting that came from Forrester is the fact that business managers want to adopt the cloud faster than the IT organizations want to adopt the cloud, right? It's those business drivers and advantages they want to take advantage of. And clearly on the IT side of the house, right, there's a lot of challenges that you got to look at and take into consideration, right? Sprawl, as those virtual machines become increasingly prolific, right? The storage demands, the network demands, are becoming huge. And we're learning that, today in most IT environments, 70% of the resources are being spent on the management and the operations, right? That's a big inefficiency there, and only 30% left to go innovate or drive new business opportunities with IT. And so that's really, I think, helping set up the driving factor in the phase shift, if you will, of why customers are looking to go to the cloud. And as you look at that, I think there's a couple of dynamics that you have to think about going to the cloud. When you go to the cloud, things change pretty dramatically. It's no longer about the virtualization of the servers or just the storage capacity. It's really about how do you create that entire infrastructure that you can provision, resource, just like you can a server. Because as applications, are driving those requirements, you can't look at one piece. It's not just about the compute. How do you expand the bandwidth and the network I/O, right? How do you add the storage capacity? When you're putting all these machines in your data center, what about the cooling and power impacts, right? And then let's talk about management software. As you add more and more things, it gets pretty complex. So you've got to begin to look at how do you converge the entire infrastructure, just not the pieces and the parts. So some of the challenges that we're seeing today around the storage, right? We talked about that virtual sprawl and the need to add additional storage. Industry fact here, and let's make an assumption for a moment, right? Forrester recently did a study about a year and a half ago that says on average, they're seeing that roughly of SAN storage, shared storage, about 60% utilization rate. Okay? Maybe it's right, maybe it's wrong, but let's use that premise for a moment. Now, as virtual machines get deployed, more and more and more of them, right, they have to use a shared storage environment. They can't use the direct attached storage within those servers. Pretty soon, if it's 60% utilization rate, as you provision more and more of those virtual machines, right, that gets compounded and it becomes exponential, right? And so now you've got to deploy, over-provision a lot of storage resource that you may or may not be using, and that gets pretty expensive, both from the hardware cost to the maintenance cost, the power and cooling, and you sort of see a pattern there. The other thing that you got to start looking at, and we understand is a pretty big challenge, is not all storage is application optimized. Right? At the end of the day, you're providing storage for what? An application to consume it, a place to store information. And if it's not application optimized, how do you get the best performance? How do you get the best management? Right? Those are adding to that complexity of provisioning to those business requirements, to those applications. And the other thing is adapting to dynamic needs. Right? Let's take a fiber channel SAN. Nothing new, right? But as you begin to scale, right, you have a SAN, you got a controller, you saturate that, now you have to add another SAN. And can you dynamically scale that storage across those two? No, right? Now it's another entity to go manage. And while you can scale there, it's not dynamic, right? And then again, when you add those resources, where's the simplicity? Where's the integration of how those pieces work? Not only how do they work in the management schemas, but how about the virtualization frameworks? And how does that integrate with the application itself? You know, how many solutions are out there today where you can go to the application, right, and set up what requirements of storage you have, and it automatically gets provisioned all the way down seamlessly? Sure, that's, you know, I guess the ideal scenario, but today, not very many places you can get there from here. So as we go through and look at cloud, you know, and talking with a lot of customers and trying to really understand, you know, what it is that they need, what are the requirements, right? And really to be able to support the dynamics of a cloud environment, they want unified, right? They want to be able to say, hey, I have got ability of storage where I can do block or I can do file. I need to do backup. And they don't want to manage it separately. They want it unified to be able to deal with those whole. It's got to be scalable, right? How do I make it scalable so that it's non-disruptive? So kind of three premises that we see here that seem to be very common themes from a customer point of view is it needs to be simple. There needs to be one single virtualized pool of resource that I can share, provision, re-provision across my environment. It's got to be disruptive as I scale, right? When I put in an additional capacity point, I don't want to have to take the time to set that up, get it going. It's a separate entity, provision it out. Now I've got multiple things that I have to manually provision. It needs to be independent. You need to be able to scale it for capacity or performance, right? And it's got to be smart. That application aware, the highly available, right? Because the more and more the cloud gets implemented, the more users you have, it's more important to keep that data available, right? And as service providers, isn't that kind of the crux of your business? Because if you can't provide that data and that compute to your customer, it impacts your business pretty significantly. So this is kind of the premise that I'm going to use against today as we begin to talk about the different kinds of way to simplify storage and the solutions that are available. So a lot of people don't realize, but HP already delivers unified scale-out storage for the cloud, right? And the two primary products we have for that are the P4000, right? This is Scalable iSCSI block storage. Some of you may know this as the former Left-Hand product. We acquired them a couple of years back, and it's based on that technology. And then we have the X9000, and that's our scalable file solution. And some of you may know that we acquired that technology through iBricks. And both of these products are based on the premise that you can scale them out seamlessly, non-disruptively. You can simplify, right? You can scale, and it's smart. So let's walk through that. And let's talk about the P4000 for a moment. So it's flexible. As I mentioned, we can scale performance and capacity online, and that allows you to match that VM resource requirement as well as the application demands, right? And if you can scale capacity by performance, you know, if you can scale your storage pool by capacity or performance, that begins to give you that flexibility, right, to adapt to those dynamic needs within your environment. It's efficient. I'm sure you guys all know about thin provisioning, right? It's been around for a while. And the whole premise behind thin provisioning is the fact that, you know, as you can have a pool of storage that you can allocate on the fly as it's needed. There's an interesting dynamic going on in the industry where to do that, several vendors are saying that you have to predefine that, you know, allocation pool and set it aside. Well, since it's now set aside, you can't use it for something else. Isn't that not very efficient? Something that the P4000 has done that's very different is we have something we call reservationless thin provisioning. And it works a couple of ways. The premise behind it is because we're scalable non-disruptively, is we need to add capacity, we can add another node, right? And then we can seamlessly scale that pool of storage. We don't have to set aside those reserves, right? We can allocate on the fly. And if it's coming up to where you're out of capacity, you add another node, it seamlessly gets pulled into the pool. And so ESG did a white paper. I'll get to you in just a second. ESG did a white paper, and they're saying that that's roughly 33 to 40% more efficient than traditional thin provisioning. You had a question? Okay, well, we're going to get into how some of these things work, and we're trying to show you how to simplify. So let's talk about how it's simple and how it speeds up cloud deployment. Single centralized console for all systems. Why is that important in a cloud, right? There's so many pieces and parts that go into a cloud environment. You've got your compute, your networking, your management, your storage. Do you want to have different elements for each one of those things? Right, as you add more and more storage, do you want to have different consoles, different ways to manage that storage? We think the answer is no, so make it simple. Make it a common console for all your storage. Integration with VMware, right? HP Matrix, speeds deployment. How does that happen? Well, if you've got a storage solution and you've got the integration, the APIs, so that you give that virtualization framework the ability to say, I see the storage, I can then go grab and provision as I need to, that you take a step out of the equation for the storage administrator or the IT administrator, right? Makes it simpler for them, it's seamless, and they can focus on doing something else. It needs to be application aware to optimize that provisioning, understanding the requirements, the data requirements, the performance requirements of that application, right? It needs to be comprehended at the storage level. And that's where you start to get the advantages, the performances, and the efficiencies in those environments. And scale, right? The ultimate place for scale is, like we say, I need more capacity or I need more performance. I can add that as I need it. I don't have to go pre-provision it, have it waiting there ready for me. As I need it, I can go get it, I can deploy it. And the beauty of that with the P4000 solution is you add a node to the solution, it automatically scales. There's no downtime. There's no additional management that's required. So that makes it cost effective, right? Because you don't have to invest those resources until you need them. And the other thing is it allows you an all-inclusive feature set, right? When you buy something, you get everything you need. So let's talk about the scalable performance. Let's talk about the scalable performance. As VMs are added, you've got your storage system, right? So I want to be able to add capacity or add performance. I can add additional nodes. And you create a storage cluster, just like you create a cluster in your virtualized server environment for that availability, right? You do the same thing for your storage. And when you do that, as you add nodes, guess what? There's something interesting that happens. Because we're based on scalable, modular x86 architecture with disk, when I add a node, I add performance because there's compute and cache. I add connectivity because you've got additional network. And I add spindles so I can get capacity and or I/O performance. And we feel that in a cloud environment, right, that gives you the ability to dynamically scale, to simplify, reduce, boost performance, right? The other thing is it's protected. Clearly, as we talked about this a little bit earlier, we cluster, we replicate. As you add nodes, the storage pool is seamlessly expanded. We then begin to replicate and RAID across the entire pool. Now that capability is pretty important because, if you have a disk failure or heaven forbid you lose a connection and you lose an entire enclosure, you don't lose access to that data. So that really becomes optimized for those virtual environments that have multiple requirements, multiple machines relying on this data set. The other thing that you can begin to do, and we feel that this is very important for those cloud environments, is how do you begin to optimize around the data types, right? Maybe you've got very performant data and you put those on your SAS-based drives. Maybe you've got more of a general purpose information or information that was there and it's become static and it's not used as often. Where with the left hand or the P4000 product, you can now create a capacity tier using SATA drives. So now you give the ability to go cost optimize that infrastructure. The other thing you might need to do is unify that storage, right? You need a solution out there that where you can put a gateway in, and now you can take advantage of both block and file capacity storage. With the P4000, that's something that we enable. So now you can, again, dynamically accommodate that internal environment based on whatever type of application and data needs you've got. It's smart, right? 24 by 7 by 365 storage. Critical for environments, right? As you leverage an environment to use internally across multiple user groups or you're a service provider, you need to make sure that it's available, right? You need that real-time site protection. One of the interesting things that we can do with the P4000 is we can take the concept of having a storage cluster, and it doesn't necessarily have to be co-located. Because the information is strived across all of the nodes, you have the ability to split that cluster up across a couple of sites, right? And you've got no additional hardware investment. So again, for that scale as you grow, for that added availability factor, the P4000 enables that seamlessly, simply, right? So as you've got virtual machines, and say that you lose, a node or a virtual machine environment, you can use vMotion, seamlessly automate the transfer of those virtual machines to a new physical server. And if you lose a site completely, guess what? Your storage is still up. So the site goes offline, the application remains online. Now, one would argue that's almost a core requirement if you're going to put together a private cloud, right? Or if you're a service provider providing that capability to your customers. So I'd like to introduce Ben Miller from BLUELOCK. I'm going to ask him to come up here and share with how the P4000 and their environment has helped them pretty significantly. So Ben, introduce yourself and a little bit about what you guys do.
Thanks, Tim. Good morning. I'm Ben Miller with BLUELOCK, Chief Engineer with BLUELOCK, and BLUELOCK's been around for a long time. Before the cloud was called the cloud, we called it infrastructure as a service. And we're honored this year to be recognized Partner of the Year 2009. It was quite a story from very, very humble beginnings, and that's, I guess, where part of the BLUELOCK story and where it plugs in with the HP comes together. At the very, very beginnings, we were looking at what it would take to be a service provider, to be able to grow as our clients' needs, as the demand came in that really wasn't very predictable in an industry that wasn't fully mature yet or predictable at that point. So we were looking at some traditional design models back then, and some of the fiber channel options we were looking at kind of led us to a decision of, well, we could start a business or we could buy a SAN. So we took a look at a few other options. I'd remembered a meeting where some folks had come out from Left Hand and talked about the solution being scalable. I said, let's take a look at this again. And sure enough, the story panned out, I guess is the long and short of it. We were able to start off fairly small, get into the industry, prove that the concept was there, and we have grown year after year explosively as the whole cloud computing and infrastructure service niche has grown. I was very impressed along the way as the promise paid out that you add a shelf, you add capacity, you add compute, you add I/O, cache, etc. It's a promise that has kept with us to this day. We've married it with the HP Blade solutions, and we've been able to buy the resources we need when we need them. The thin provisioning has allowed us to kind of keep ahead of the curve, but be able to predict a little bit better how much storage of what type is needed when, and slide in and purchase the right resources at the right time. So that's it's been a great solution for us. It has been a simple solution. I didn't have a team of highly trained SAN gurus at my disposal when we got started. So this was a great way to start off very simply. and have been spoiled ever since. As we've grown, the simple management of adding storage, adding compute, adding I/O has let us really focus on the business of being a full-service cloud provider rather than focus on, okay, what do I need to do to move data from one spindle to the other, or where's my hot spot, or those types of things. It's just been a simple, ongoing operational task. We've grown our business and are providing both the public cloud storage, but we also provide private cloud. We manage the clouds both publicly and privately. And one of the neat things with the HP left-hand solution is that it allows us to put the right amount of storage where it needs to be, whether that's in a private cloud or whether it's in our public cloud. And one of the neat pieces of that, too, is it allows us as Tim mentioned there, it allows us to replicate from private to public or public to private, allows us to move workloads, allows us to use DR or SRM to manage where the actual workload is running. So this slide here talks about a little bit about our pod mentality. We've grown our business by creating pods of resources, and both the HP blades, as we add them to the blade chassis, and the HP 4000s have just been a slide and go. You buy the product, you put it in place, and you grow. So as our demand has grown in the public cloud or any of our private clouds that we manage, the ability to slide in more shelves and more blades has been seamless and simple. And that's been a differentiator in terms of flexibility for BLUELOCK. It's been a promise. It's paid off since the beginning, and currently we still use the product underneath all of our pods, our baseline storage, our professional cloud, and our enterprise cloud solutions.
Thank you much.
Thanks, Tim.
Thank you very much, Ben.
Yeah, come visit us at 639. Any other questions, or just want to talk over any of that story?
Great. So again, what we're trying to do here is talk about some of the requirements that you have in a cloud environment and how they can be simple, how they can be scalable, how they can be smart. And here's a real-world example of how that's being done today. So let's talk about the X9000. Maybe you need file capability instead of block capability, or maybe you need both, and we'll talk about that in a second. So if you've got explosive file growth, right, there's ways to go tame that, right? And HP offers a solution for that, and it's the X9000. It's ultra scalable. Imagine you can have up to 16 petabytes in a single storage pool that's commonly managed with common data services across it. The goal here, right, is to make it, future-proof. As you need that capacity, just like we showed, with the left-hand solution in BLUELOCK, you can add that capacity or you can add that performance as you need it, non-disruptively, seamlessly, right? Again, simplifying it as well as scaling it. And we also can automate it, right? With the X9000 solution, we can automate that tiering, not just at the individual node, but across the entire storage pool. And I'll get into this in a little bit later, but that really gives users the flexibility to cost optimize as well as performance optimize where they need to make those investments. It's simple. The X9000 has one architecture, and we can meet a lot of different demands with it, right? We can, we have a solid state option here. So if you need that high performance, cache capability, something to think about. As those applications, right, you've got that database and you want to really put together, that high performance cache for the metadata and really get that thing humming along. We've got a SAS box for high performance. You've got a SATA box for that mid-range performance, and you've got an extremely scalable product. And what this allows the environment to do, right, is again, as you add additional nodes, you remove those bottlenecks. You improve that bandwidth. Why? Again, this is built on industry standard modular components. As you scale, think about your requirements. You need to add additional capability for compute and cache for performance. You need to add additional network connectivity. And of course, then there's the capacity. So look for solutions that allow you that kind of flexibility, but deliver that kind of capability, right? The next thing is you want it to be cost optimized. We talked about not only the tiering, right, but what about the data retention, the migration? And you want common management across that namespace. You don't want to have to manage these individual pieces, these individual nodes piece by piece, right? You want to be able to manage it seamlessly again, so that your IT resources can go focus on other things. So let's talk about how it works. It's very similar to the approach that we had with the P4000, right? As you've got virtual machines and you've got applications that you're delivering on those virtual machines, is the need to grow those. You can add nodes, again, growing that common data pool. But it gets a better story than that. Maybe you've got existing storage that you want to take advantage of, that you need to use with this. Look for solutions that can add a gateway, right? And now you can take that existing block storage and you can pull that additional capacity into this single namespace. And there's a couple of advantages that it gives you, no matter whose approach you want to take here. It can be anybody's storage behind a gateway, right? But what it allows you to do is as you pull it into that single namespace, now you can drive those data services across all of it. Again, you don't have to manage that or deliver that at the individual box level. So if you wanted to replicate, if you wanted to back up, you're backing up one pool. Again, simplifying the capabilities, right? Putting less stress, less workload on your IT managers. Let's talk about tiering. This is one thing that I think is a really distinct advantage across an entire pool, not at the box level, but at the pool level for storage. Right? With the X9000, we can do policy-driven tiering. Whether you set a tier 0 with solid state, or a tier 1, or a tier 2, or even a tier 3 with a disk-to-disk backup, right, for that nearline level storage, you can set up a couple of dynamics here for that data movement. It could be based on user-defined parameters. It could be based on application requirements. It can be based on cost requirements. And we can dynamically assign segments for that optimal efficiency. Think about it. Let's take a policy perspective. You've got some storage, right? You can deal with it at either the block level or the file level with this policy management. But maybe you've got some content that is, hasn't been accessed for, months, right? You can set those automated policies to go do those polling, find that, and move it from maybe your tier 1 to your tier 2 storage. And now you've freed up that additional capacity for your very active data. And now that data that you've moved off starts being used again. Well, you can have the policy that can automatically move that back. Again, it allows you to drive the optimal performance, right, of your resources, but also manage the cost of those resources. And you can do this automated or manually, right? It gives you a lot of flexibility here. I want to talk about another example of this. MD Anderson is a very, very large medical organization in the Houston area. And their cancer center actually is one of the leading cancer centers in the world. Right? And they had a very, very large infrastructure. It was distributed. It became very complex. And they came to the point where they realized that they have to manage that infrastructure differently because they weren't able to do the research, do the modeling, provide the client, the patient information in a timely manner. And one might argue that medical information is probably some of the most mission-critical information you can have out there. And so it came down to they had to make a change, and they looked at the X9000 because it was simple, it was automated, it had disaster recovery capability, they could get that performance as they scaled, right? And one of the biggest reasons they use it is they could take advantage of their existing storage. They had an existing SAN with over 800 terabytes of content stored there, right? That's not something they could just walk away from, right? They needed to make sure that they could take advantage of those resources, the data on those resources, in a non-disruptive way, and protect the investments that they already made. And so they were able to do that. The way their architecture that they went to here on the far side of the screen is, they are using one pool, one set of infrastructure for multiple uses. On the top, you see where we note there's clinics. They've got multiple clinics, around the Houston area, and those clinics need access to that patient data. So they need a system that would be able to accommodate, those files and that growth, right? But they also had their performance side of their research side of the house. And there they've got, high-performance computing clusters to be able to do that modeling, that genomic stuff, the cancer simulations. And so very much a mixed-use environment with different requirements. And by putting in, a scalable file solution with a single namespace, they can meet and accommodate both sides of the house, if you will, right? They were able to take and use gateways and pull in their existing fiber channel storage and take advantage of that in that common namespace, right? And they get the advantages of when they do that is not only accessing the data, but segmenting and tiering that data, right? Being able to protect it, replicate it, all in a common approach. And it's done some pretty interesting things for them, right? They can now do more research and spend less time, looking at how do we manage the clusters and making those resources available for their researchers. They can run simulations much faster, right? In minutes instead of days. They gave an example where they were able to run a patient simulation in roughly 90 minutes, right? Instead of a couple of days or a week or so. And so while the patient was still in a clinic, they were able to come back and say, hey, here's the protocol that we think would work. Here's what we think the outcome would be. Now think of the quality of life of that patient. They don't have to sit for multiple days wondering what their outcome is going to be, right? So here's an example where the technology is actually making a difference. And again, faster compute, more data modeling means they can improve those therapies. They can get some distinct business benefits because of what this technology is able them to do. So you've got a couple of ways that you can scale out storage, but I think there's some other things that no matter which direction you go, you need to think about when you're doing your cloud transformation, right? There's the services side and there's the solution side of the house. Do you need some help looking at the strategy and analysis? Is a cloud right for you? Pick a partner that can help you do that. Do you need to figure out how to plan and design for your environment, right? Do you need help with the implementation? Is there technology support? Look at your partners if you're solution providers, right? How can you make that simpler to deploy out for you? How do customers figure out how to get those resources, right? And the other thing is, a couple of things to consider. Do you need a complete turnkey solution? Do you need something that you just take, you buy it, you put it in place, it's ready to go? Or do you need an integrated platform because you want to take advantage of some of the things that you already have and maybe use those modular building blocks? So some things I think that, I would suggest that you look through and consider as you go and you deploy your cloud environments. So we say that it needs to be simple, it needs to be scalable, it needs to be smart, right? You need that one virtual pool of storage. It needs to be commonly managed. It needs to be simplified. How do you do your replication, your disaster recovery, your snapshots, your backup from one place instead of multiple places? How do you disruptively scale, right? When you need those resources, how can you put them together, add them in, have them self-absorbed, right? Expanded so that there's less work that you have to do, there's more uptime for your application, right? When you add those resources, how can you get rid of some of those hotspots and get that load balancing capability across your solution, right? These are things that I really think you can help take some of those dynamics, the challenges away from you and let you focus on other things. How's it smart, right? Look for solutions that are 100% available. Again, when we talked about the P4000, right? How do you look for solutions that actually takes cost out of the equation, right? With the ability to put in a multi-noded solution, take that, split it apart across multiple sites, yet you don't have to make any additional investment. What other vendors can make that promise to you guys? So again, we wanted to sit here and talk about what are some of the requirements and how HP can fulfill some of those requirements. And we've got a couple of ways that we can do that for you. So there's a couple of other things that I think you can go learn about here at VMWORLD. The Dallas Cowboys and Converged Infrastructure. You can go to that session and learn about, how taking that holistic approach of a converged infrastructure has allowed them to enhance their business and actually do things that they weren't able to do and create new business opportunities and generate new revenue streams. On Wednesday, Mark Potter is going to talk about fast tracking for private cloud transformation and how turnkey solutions can be delivered. So where you've got uptime in a day, not days or weeks or months, right? And then, of course, there's desktop virtualization. I know this is kind of late on the last day, but if you're looking at doing virtualized client, right, virtualized desktop, learn how, some of the deepest integrated VDI solutions with VMware at some of the lowest cost per seat, in the industry can be deployed pretty quickly. So I want to open it up here for some questions. So let's go ahead with some Q&A. I'm sorry, was there a question there in the back? There's a microphone here. So a couple of people asked me some questions, and let me ask you guys, maybe get some feedback from you guys. I had somebody ask me, as they're moving machines, right, how do they make sure that they remove some of those I/O and bottleneck pieces? And I thought that was pretty interesting because he was saying that there seems to be a pretty common bottleneck there, and he didn't think anybody could solve that. And so I think there's an interesting thing to consider, right? When you're adding those virtual machines and get rid of those bottlenecks, choosing a solution that, again, adds those multiple layers of resources. It's not just about the storage, but it's the compute, the cache, the networking, the I/O, right? So look at solutions that have that kind of capability, that flexibility. Any other questions that might come up here? I know, I believe you had a question earlier. You want to share that question again? So I think there's some other people that probably would be interested in that.
In working with existing environments.
There's a microphone to you. What? So say it and I'll repeat it for you.
In working with clients in existing environments with existing storage infrastructure, many of our clients reach the capacities that they have building out their cloud environment. It's always complex and difficult to discuss with customers how to expand those environments or expand onto other platforms to deal with the problems that go along with that.
So the theory that he was posing here is, as they provide additional services to their clients, they're a service provider, a solution provider, as customers kind of reach that peak of, capacity and performance through their systems, how do you be able to add systems, migrate systems in a seamless fashion? And there's a couple of ways you can do that, right? If you deploy, say, a scalable file solution, right? You can put a gateway in there and you can pull those existing resources into that common namespace, right? And now you've got that seamless way to maintain those resources yet scale with additional capacities, right? And the management of that becomes seamless, right? Because you now have an integrated console to do that. There's another way that you can do that if you're, say, in a fiber channel world, right? Where, look for a solution that has the ability to go from physical to virtual back to physical, right? So where, again, if you want to add a completely new infrastructure because you need different scale, different capabilities, newer technology, there's a way to go do that. Our EVA and our XP products on the fiber channel side have that kind of capability to where you can take your existing physical, migrate it to a virtual, right? Put in the new hardware and migrate it back to the physical. So again, actually non-disruptive for your customer completely, right? And with obviously the ability to, with vMotion, move those those virtual servers onto different physical machines, you start to kind of pair those capabilities together, and it gives you that flexibility. Go ahead.
Hi, I have a quick question regarding P4000. You mentioned that one can do replication for reliability. Can it also do some RAID 5 or RAID 6 based reliability?
Sorry, I'm not quite understanding what you're saying.
So for P4000, you mentioned it can do replication for reliability.
Right.
Can it also do RAID 5 or RAID 6?
Yes, you can do RAID 5 with that. One of the nice things about the way the P4000 works is because it's clustered, right? So not only do you get RAID within each of the nodes, right? You've got the x86 server and the controller, right? But now as you're adding additional nodes, right, you're striping and replicating that data across the nodes. So that availability, think of it as network RAID, right, across those nodes. So you're getting the added benefit of that. So not only are you protected at a disk level, you're now also protected at a node level.
So does it support RAID 6 or no?
No. I mean, if you look at RAID 6, but here's a reason why, okay? When you add RAID 6, you set a couple of additional drives so you can support drive failures. With the way that we're clustered, you can actually support more failures than you can, right? With a RAID 6, you can support up to I think 4 different drive failures simultaneously in a single node because of that.
What do you need for the cross-site? Requirements. You showed a gig window. Do you need a gig to do this?
You need a gig. I mean, there's a minimal latency requirement. That's a really good question. We've got Adam Carter, who's our specific product manager for this product, in our booth. And I would love to be able to answer that, but I got to tell you, Adam's going to have to answer that for you. Okay? But there's a tolerance level, and we've got a white paper on that specifically as well.
So why is this a private cloud topic?
Pardon?
Why is this a private cloud topic?
It's a private cloud topic because we're trying to illustrate that in a private cloud environment, there's some additional capabilities that you need to think about, right? It's not just putting together, a simple storage array, right? It can be a public cloud. In fact, our friends here from BLUELOCK use this behind, as part of their infrastructure for a private cloud, right? Where we wanted to focus on is HP is not a public cloud provider, right? Right. Well, enterprise services may do that, but we wanted to show how to put the infrastructure in for cloud environments. Any other questions? All right. Well, thank you very much for your time. I hope we were able to give you some insight and some interesting information.